Welcome to another academy. In this video, we are going to discuss about stereographic projection. Stereographic projection is a mapping from the unit sphere x square plus y square plus z square equal to 1 onto the extended complex plane. Extended complex plane means the set of all complex numbers taken along with infinity. Okay. So what we are doing here? See, this is the unit sphere and this is the xy plane or the complex plane. Okay. Here this point n is 0, 0, 1. What we are doing here is for every point P on the complex plane, you join it by means of a line with this point n 0, 0, 1. Okay, that is I am joining this P for every point P on the complex plane. I am joining it with this n. Okay, so this line will meet the surface of the sphere at exactly one point and that point is called Q corresponding to this P. Okay, so for each and every point on the complex plane, I can find such a Q here. Okay, unique Q, that is also unique. And in the other way, for every point on the sphere, S, I can find a point on the complex plane except this n. For this point n 0, 0, 1, I am associating infinity. This mapping is called stereographic projection. This is a bijection. Okay, right. So how to identify, if I know the point on the complex plane, how to identify the corresponding point on the sphere, and similarly, if I know the point on the sphere, how to identify its image on the complex plane. That is what we are going to see in this video, right? Okay, if x1, x2, x3 denote point on the sphere, okay, on the sphere except this, okay, then the corresponding point in the complex plane is given by z equal to x1 plus I x2 by 1 minus x3. Okay, here this z is nothing but x plus iy. So the real part is x1 by 1 minus x3 and the imaginary part is x2 by 1 minus x3. Similarly, suppose z equal to x plus iy is the point in the complex plane, then the corresponding point on the sphere is given by x1 equal to z plus z bar by mod z square plus 1, x2 equal to z minus z bar by I into mod z square plus 1 and x3 equal to mod z square minus 1 by mod z square plus 1. And what about this n 0, 0, 1? This corresponds to what? Infinity. That is the point at infinity. Okay. So this mapping is called stereographic projection. Now let's see few problems based on this stereographic projection. Okay. See. The first problem, for z equal to I, find the corresponding point on the unit sphere. Okay, that is what is the point in the complex plane? Z equal to I. So for this we are going to find the corresponding point on the unit sphere. Okay, now z equal to I means what is z bar? Minus I. What is mod z square? Square root of real part square plus imaginary part square. Here real part is 0, imaginary part is 1. So 0 square plus 1 square. Okay. So it's simply 1. So mod z square equal to 1. So how to find the point on the sphere? The points are given by x1, x2, x3 where x1 equal to z plus z bar by mod z square plus 1. So when you add these two values, it will become 0. So when the numerator is 0, the entire thing is 0. And x2 is given by z minus z bar by I into mod z square plus 1. So I minus of minus I will become 2I by I into mod z square is 1 plus 1. Okay, so 2 get cancelled and I also get cancelled. So finally what we get? x2 equal to 1. And x3 is given by mod z square minus 1 by mod z square plus 1. Mod z square is 1, no? So 1 minus 1 will become 0. So the point corresponding to z equal to I is what? 0, 1, 0. Okay, one more problem. For z equal to 2 minus I, we are going to find the corresponding point on the sphere. So z equal to 2 minus I means z bar is equal to, its conjugate is equal to 2 plus 3i. Mod z square equal to what? 2 square, real part square plus imaginary part square. What is real part? 2. 2 square plus imaginary part is what? 3. Minus 3. So minus 3 the whole square is 9. So 4 plus 9 equal to 13. So what is the respective point, corresponding point on the sphere? x1, x2, x3 where x1 is given by z plus z bar by mod z square plus 1 equal to, what is z plus z bar? Add these two values. Imaginary part get cancelled, no? So 2 plus 2, 4. 4 by 13 plus 1. So 4 by 14, it's 2 by 7. And x2 equal to z minus z bar by I into mod z square plus 1. What is z minus z bar? So 2 get cancelled, minus 3i minus 3i. So it will be minus 6i by I into 14. So I get cancelled, so minus 3 by 7. And x3 equal to mod z square minus 1 by mod z square plus 1. So 13 minus 1 is 12, 12 by 13 plus 1 is 14. So it's 6 by 7. So the corresponding point on the sphere is 2 by 7, minus 3 by 7 and 6 by 7. Okay, let's see one more problem. For the point 1 by root 2, 1 by root 2, 0 on the unit sphere, find the corresponding point in the plane. So a point on the sphere is given, you have to find the corresponding point in the complex plane. So here x1 is 1 by root 2, x2 is 1 by root 2 and x3 equal to 0. So this is a point on the sphere. What is z? Z is given by x1 plus I x2 by 1 minus x3. So 1 by root 2 plus I 1 by root 2 by 1 minus 0. So what is this? 1 by root 2 into 1 plus I. So this point is mapped to 1 by root 2, 1 by root 2, 0. Okay, one more problem. For the point 1, 0, 0 on the unit sphere, what is the corresponding point in the complex plane? So x1 equal to 1, x2 equal to 0 and x3 equal to 0. So z is given by x1 plus I x2 by 1 minus x3. So 1 plus I into 0 by 1 minus 0. So what is that? 1. So this is the corresponding point in the complex plane for 1, 0, 0 on the unit sphere. Okay, that's all. Thank you.